Hi, in this video, we'll see about the characters in C, the character arrays in string C, which are also called as strings, how to handle the single character, how to handle a string of characters or array of character, and how to do operations based upon it. This is one of the most important chapter you can consider in this entire course because most of the embedded system developer do struggle with character operations. With int operations or with numeric operations, most of us are pretty comfortable, but usually we struggle with string characters or character operators. The only reason being, we have not given any detailed study about it. So that's the same thing which is included right now in this video. So pay close attention and try to perform the practices shown. Now, just like we have seen that there is an array of integers, there can be an array of characters also. But before that, let's see some basics about characters. Now, a very fundamental thing about character is anything which is printable. Any character which is printable is basically an ASCII code. Now, if you ask me what is ASCII code, then ASCII code is basically a representation of printable characters into decimal numbers. So let's see ASCII chart. It's important to have a view at ASCII chart also. So let's open a new tab. Let's open this image. Okay, it's very small. This one sounds good. Okay. Now look at this. When I say ASCII chart or ASCII character, what it simply represents is C. In decimal, there are numbers from 0 to 127. All of these are nothing but pure decimal numbers. And when you have to print a character onto the screen, one of these decimal numbers is used, but it is interpreted as a text character. So if you want to print 0 onto the screen, remember always 0 is not printed by passing 0 to the printing function, but we pass 48 to printing function. So look at here, 48 is equal to 0. So when you pass 48 to printing function, then 0 is printed. The same thing is being done so far using printf function. Why we need to do %d and then printf? That is because we are formatting the integer to be printed in its text format. So the printf function is doing the conversion from integer to ASCII for you. The problem with embedded systems comes because we don't have printf function in embedded system. So what we need to do is we need to manually convert our numbers into their respective text representation. For any kind of number you may have, remember one thing, we have only 10 ASCII letters from 0 to 9. So for example, I have to print 129, then I have to print the ASCII of 1, ASCII of 2, and then ASCII of 9. So on and so forth. Don't worry, things will get clarified as we progress. Then these are all the special characters, then these are all the capital letters A to Z, then small letters A to Z, and all these characters. Now you see, if you see, every character is represented by a printable, or every printable character is represented by a number, and these numbers start from 0 and end to 127. Meaning we have only 7-bit ASCII code to store any particular printable character or any particular printable letter. Now because of that, what is done in C programming, we usually use char variable to store strings or even a single letter. The char variable is used because the char variable only occupies 8-bit of memory in the computer, and therefore it is the optimal choice for storing the characters. So unsigned char or simply char can be used to store a character, and an array of these char variables is also called as string. Now let's see one by one. So if I have to talk about a single character, then let's see this. You can take a single character from the user and print it using a directive, printf directive %c. Now let's try it out. So let's take a new empty file. I'm saving it as char_1. I'm going to keep all the programs as char_1, char_2 and so forth. So void main character A, printf /n/, enter a character, then scanf, and what we do here is %c. Now when you do %c, what it implies is whatever you enter, it is treated as a character, and therefore the ASCII of that character is stored. Instead, when you do %d, what we do is whatever you enter, it is converted into number and then it is stored into variable. When it comes to character scanning, whatever you give, A, B, C, D, whatever it can be, it is stored as it is into this variable %c. Now I'll clarify this thing in a moment. Please pay close attention to this video. Now we have scanned C as character. Now what we can do is printf. Now let's try printing the char. And then printf /n/n %c, C. Now see, I have scanned it using %c and I'm printing it using %c. Let's see what happens after this. What is the mistake here? C is undeclared, sorry. Its variable is called as A here, my mistake. And now let's run it. Again an error. I juggle back from Python to C, so sometimes I get to do these mistakes. So enter a character. Now what I'm going to enter here is, let's say A. Okay, let's say capital A. And hit enter. And now let's try printing the character and see what we get is capital letter A. So we scanned A, we printed A. Now let me show you a catch here. What happens when you, instead of making it %c, if you print it using %d. Now we know that we use %d to print the numeric format. Now let's just see it first and then we'll try to explain. Enter a character, I'm giving capital A. And now let's try printing the character, and what we get is 65. Now let me tell you the meaning of this thing. What happened is, when you entered character A from keyboard, you are not actually entering character A, but you are entering its ASCII code. Computer doesn't understand these printable letters. Computer can only understand the ASCII codes. So whenever you type A here, we are seeing it as A, but in the beyond or behind the scene mathematics, it is being stored as 65. Look at it here. When you type capital A from computer screen or computer keyboard, it is stored as decimal 65. Isn't it? Now, when you try to print it using %d directive, what happens is %d directive has a function to convert this into its respective ASCII. So 6 will be converted into ASCII, 5 will be converted into ASCII, and then we get a result 65. But when you use %c in printing the character, it doesn't convert it into ASCII. It directly sends the 65 number onto your computer screen. And when you pass 65 number to the computer screen, then it is printed as capital letter A. You might want to go through this video again and again because it may cause slight confusion. Now, to avoid the confusion, let me also write down some notes here. How char is scanned. So when we scan a char using %c directive, then the decimal equivalent of the character that you entered is saved in the variable. When you print it using %c directive, then the decimal number is, this is important, as is sent to print buffer, and since it resembles an actual ASCII code of a letter, the letter is printed. Now to demonstrate this in a different way, look at it. If you don't scan it like this, for example, I'll just comment this line here, and if I directly write down A is equal to 69. Okay, A is a character. I wrote A is equal to 69. If I print it using %d, you know what is going to happen. With %d, what is going to happen? 69 will be printed on computer screen, as you can see here. But if you try to print it using %c directive, then what will happen is 69 will be directly sent to the print buffer. If 69 resembles to any printable character, then that character will be shown. Look at it. So 69 resembles character E. So when you do that, when you print it using %c, it will not print 69, but it will print E. Look at it. You have to gain an absolute clarity over this point, which is very, very important. Remember, it has nothing to do with int or char. Many people mistakenly teach that int is used to store numbers and char is used to store letters. It's not like that. You can very well use int here. Some compilers may throw you error. Most embedded compilers will not throw you an error. Let's look at it here. See, there is no problem. Many people will scoff with the idea that you cannot print A with %c directive. Yes, we can. Many people also say that you cannot store a letter in int. Yes, we can. I just did it now. Let's see. Now see, I tried to print Z here with double quote. In C, it needs to be single quote. Whenever you are giving a single variable or single character, it needs to be single quote. See here. So always remember, int and char has nothing to do with storing numbers or letters. It is all to do with the memory that it occupies. Since character doesn't require 16-bit or 32-bit location or 32-bit address like int, what we do is we use char instead of it. Try to do number of different permutation combinations with it. Try to take anything, print it with %d, print it with %c, and you will get an understanding of it. There is one more way to look at it. If you have to print the ASCII of any letter that you scan from the user, then you print it like this. So letter is %c and ASCII of that letter is %d. Now instead of manually giving A equal to Z, let's scan A. Now I'm going to give @ and enter. Now the letter that you have entered is @ and the ASCII of that letter is 64. Is it true? Let's validate. So @ has a decimal value 64. This is very important. Whenever you will be dealing with embedded systems, you will understand these things very well. For now, just experiment with this and continue with the next lecture, where we will try to create a string out of characters and then try to print it. Try this code yourself and let know me of any doubts if you have. Thank you for watching this video. We are looking at the character operators in C programming, and we have just seen how you can accept a single character using the function scanf, and we printed it using printf. Now, if you want, the same thing can also be done using a function called as getChar for accepting and putChar for printing. So putChar can be used to print a single character, and similarly %s can be used to print a single string. Now we haven't yet seen string, so let's try to use, or let's try to understand the string operation. So we'll see that presentation later on. Now let me save it as char_2. In char_2, what I'm going to do is A is equal to getChar. This is how you can accept a character, and you can simply do putChar to print a character. These functions, scanf, printf, as well as getChar, putChar, none of them are available in embedded platform. I'm just showing this to you for information purpose. So I accepted P and printed P because you need to clarify these things very well. Now this is okay with get char and put char. Now let us try to build a string. So I'll call it char underscore 3. Now a string is nothing but a character array. So let me write that line here. String is a character array which ends with letter 0. 0 is called as null terminator in C. If you don't append this 0 by the end, the C compiler will automatically append it. Let me show you how the character array goes. So if I have to declare character A as string or array of characters, then I'll simply pass on a size to it. So char A of 10 is basically what? It is basically creating a string out of A. Now how you can store values into string? You can store values into string in both ways. One, our conventional way of creating string, where we write down each letter like this. So W, comma, E, comma, L, comma, space is also a character, comma, C, comma, O, comma, M, comma, E. So this is one way of building your string manually as a string array, or you can directly write it down like this. Both of these operations are welcomed, or both of these operations are valid. We'll test them one by one. So first of all, I'll just skip this first kind of declaration and then we'll try to print it. Now remember, you cannot print a character by simply doing printf %c, comma, A. Because now A is not a single variable, A is an array of characters. So when I do printf %c, comma, A, see what happens. What's the error? Expected expression before this starting curly bracket. Just a moment. Okay, so I made a mistake here. So you need to declare it directly like this. Okay. And now let's run it. Now see, nothing is printed because you are trying to print it using %c. Now instead, when you have a character array in your hand, what you can do is you can print it using %s. When you pass on %s, it simply tells printf function that whatever is coming is a string variable, and therefore you can print it directly using, or the entire string variable should be directly printed. Let's build and run this, and you can see welcome is printed here. Similarly, if you have to declare A is equal to welcome, let's see how we can print it. So I'll comment this line and I will uncomment this line. I'll just write down char A is equal to welcome. Instead of giving this space in between, I'll just do it like this. Welcome to C coding. You can also append new line character in the same string, and you need to declare it like this. So character A of, let's say, 20. I have more letters, so I am putting A of 20. Welcome to C coding, and a new line has been received. Now this is about printing a string. Okay, I'm keeping all the codes commented. It's your job to please uncomment those codes and then try it. Okay, I have also forgotten to do hash include here, but since the codes were previously compiled, it ran. Now this is about printing a string. Let me take a new program. Let me save it as char underscore 4. Now how will you receive, or how will you accept, or how will you scan a string? Now there are two ways to scan a string. Let me just do hash include first. And for this, we will also use this another directive called string.h. Remember, stdio.h may not be available in embedded compilers, but string.h is always available in embedded compilers. So all string operations are available with embedded compilation. Now let's see how we can scan a string. Now the first method of scanning the string is very straightforward. What you can do is char a of 20 and then simply printf, let me do /n/n, enter a text string. And then what you can do is you can scanf it using %s. Similarly, you printed in the same manner, you can scan it using %s and then you can print it. So printf %s comma a, new line, and let's print here. Let's print this string now. Now what we just did is we scanned a string and now we are trying to print it. Now this is %s. You're directly scanning a string using %s. It works very well. Enter a string. So welcome to string operations. And now let's print this. While printing, what happened? Only welcome part got printed because the string is split at space. So this scanf function will accept your string without spaces. So welcome to C programming here. Welcome to C programming here. This is how you can scan a string, print a string. Problem being, in embedded platforms, you don't have this luxury. You don't have such a kind of scanf function. So when it comes to scanning the letters, scanning the characters in embedded platform, you cannot use scan function. Or if you have to use scanf function also, there is some kind of input function in embedded platform, but directly %s cannot be used. Now in that case, what we do is we input the string in a different fashion. Let me call it char _5. And the code here will be something different. So hash include stdio.h, then void main, and then let's see that. So we'll have to have a int variable. We'll have to have the char variable where we want to save the string. Let's say my of 20. And then you will have to manually create a for loop. So for I equal to 0, I less than 10, if you have to accept 10 characters, I plus plus. And then what we'll do is, in each iteration, I'm going to use scanf. Now, this scanf can be any other function which is accepting data on your embedded platform. Maybe something coming from serial port, maybe something coming from sensor, and so and so. And I'm going to save it into my of I. So basically, just like int array we scanned, this is how char array we are scanning using for loop. By the end of this all, what will happen is you will get that entire character array into the variable called my. Now let's print it. Remember, what we need to do is, again for printing you can use for loop, but now I'll just print it using %s because you've got the idea now. Now remember, we have to pass on 10 numbers. That is important. Okay, what's the problem here? For I equal to 0, I less than 10, I plus plus, we need to declare I here instead of A. Let's build 10 letters. So let's say A, B, C, D, E, F, A, B, C, D, E, F, G, H, I, J. Now while printing, something gone wrong because the C programming structure cannot understand where a character is ending. So what you need to do here is, you need to append my of I is equal to 0 or my of I plus 1 is equal to 0. That is the null terminating character. let's try it once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again the same problem. Let's try to debug. Sorry, I have to specify the string here. Let's not give the null character and see if it works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's working. The null character is automatically appended. But remember, in embedded platforms, sometimes it may happen that the last character 0 is not considered, so you might need to give it manually. Now, this is how you construct a string in C. Either use scanf or use the scanf %s function. Similarly, there is getS function also, which you can give it a try. I'll be providing you the function, or I'll be providing you with sample codes to test with the getS. And in the next video, we'll see how we can perform operations onto it, how we can check whether a string consists of some particular desired number or some particular desired text or what. Let's see the string functions in our next video. Thank you for watching this video. Hi. We are looking at the different string operations in C, and we have just laid a foundation of what is string or character array. Now, most of the times when you are doing embedded systems programming, what will happen is, as I told you, this %c, %s putchar getchar function or putS getS function or even printf scanf functions are not available in embedded programming, but they are available on the desktop C compiler. Therefore, we are studying with respect to the desktop compiler. Now, when it comes to embedded system, or when it goes into the embedded domain, what will happen is probably this input is coming from computer or from GSM modem or from Bluetooth or probably any number of things. So a microcontroller or a system can accept data serially and can print out the data serially, or your print function can be done on an LCD or a graphics display or an OLED display. In any such case, and in many cases, you will need to compare whatever that you have received. Now, to compare string or to compare characters, there is a very simple way. First thing is, if you have to compare a single character with something, then this is how you do it. So it's very straightforward. It's using the basic if loop. So if my is equal to A. That is, if you want to check if my consists of A or B or C or for that matter, any other letter. But the problem comes when you try to compare a string. With string, the problem is like this. You cannot just directly write down, let's say, like if A is string, for example, then you can't write down if A is equal to welcome. So when it comes to string comparison, thing becomes a little bit different. If it is a single character like this, you can do it in this way. But if it is a string, if it is a character array, then this kind of declaration does not work in C, or this kind of comparison does not work in C. And instead what we do is we use this special function called strcmp. Now basically what strcmp does is it tries to compare the two past strings. So let's say s1 and s2. And this function returns 0 if they are equal, and this function returns non-zero or some different value if they are not equal. Now, because of that, what happens? The declaration or the syntax goes like this. So, if strcmp a comma your desired text which you are trying to check equal to 0, it means the string is correct or the string is welcome, and then you execute something. Now, just to give you an example, let's try to write down a program. A program in which what we will try to do is we will try to accept a string from the user, and let's check if the string is time. Okay. Now let me call it string_1 program name. Hash include stdio.h void main. Also make sure that you do hash include string.h. void main, uh, character A of, let's say, 20, then printf /n/n new line before and after. Please enter a text string. Now all we need to do is we need to check whether whatever that you have given from the command prompt is time or not. So I just want to say check if it is time. So it goes like this. First let's scan it. So scanf %s comma %a, and then if strcmp a comma time is equal to 0, then let's print something. Printf you have entered time. Now this can be anything. This can be light on, light off, stereo on, TV on, TV off. You may need to check number of different such strings when you are working with embedded domain or when you are working on embedded systems. So in every such case, what you will do is you will have multiple such strcmp. For example, if I have to check time, then I will write it like that. And if I have to, let's say, check machine, then I will write it like this. I can also do this thing. So if it is time, then do this. Else if it is machine, then do this. And lastly, what I'll do is I'll write else. Means if it is not time, if it is not machine, it means printf you entered something else. Likewise, you can have as many if conditions as you want. Let's give it a try. So the program will first, again I made a mistake, so print f. Please enter a text string. So my name is Amit. You have entered something else. Program done, closed. If you give time, you have entered time. The comparison is matched and it executes. If I give machine, then also the comparison is done and it says you have entered machine. So this is how your text related programs or text comparisons can be done. Now there are a number of different string operations which are supported, which are like this as shown here. So strcpy is used to copy the string 2 into string 1. It means whenever you want to copy the text from one to another, you can use strcpy. Concat operation or strcat operation will be used when you want to concat the string s2 on the end of s1. For example, let's say s1 is hello and let's say s2 is world. And when you want to concat the two, when you want to combine the two as if hello world, in that case what you will do is you will use this strcat operation. strlen operation is also sometimes important. Let's say if you are using for loop and if you want to execute the for loop for the length of your string, then what you do is you may want to understand the length of your string and then based upon it you can take a decision. So strlen will give you the length of string. We have just seen this strcmp, which is used to compare the two strings, and this strchr and strstr, we'll see that later on. So these are the simple trials with strings. I'm going to give you some programs about it. I'm going to give you some sample programs about it for execution. So try those programs on yourself and also see if you can generate the output for them. Thank you for watching this video.